Welcome to 2D Kinematics Drawing Vectors. So we're going to start by labeling the main directions on a compass. So we can look at this compass below. Go ahead, pause the video, and label this. Okay, so if we label them, we can go through. We should be familiar with north, south, east, and west. You can also, on these, think of it in terms of degrees. Now, when we're in a trigonometry class, we normally think of this as 0 degrees here, and you go around like this. But in physics, we usually think of north as 0 degrees. So if we look at it that way, we have this is 0 degrees here, and we usually go in a clockwise direction. Okay, so if we look at it this way, we've got this is 0 degrees here. Turn that dinging off. This is 90, this is 180, and this is 270. Okay, and then we can do the 45-degree angles. Obviously, since this right here is between north and east, this is northeast. Here's southeast, here's southwest, northwest, and obviously the angles follow suit. If this is 0 and this is 90, this would be 45, 135, 225, and 315. When you look at a vector is something that has a magnitude and direction, and then we draw it with a line with the arrow at the end of it. And sometimes you might see like a little dot at the beginning. When you draw a vector, like here we have a green vector right here, you would give it an angle. You could say, if you're just saying generally, this would be southeast. But if you want to be more specific, you could call it, it's at 113 degrees. Or you could say it's east 23 degrees south, because here, if this is 90 and this is 113, then this would be 23 degrees, okay? So it's 23 degrees south of east. So you could write that like this, east 23 degrees south, or 23 degrees south of east, whichever method works for you. Here's another example. You could say that this, if we went all the way like this, all the way up to here, that would be 270 plus 15, or 285 degrees. Or we could say it's 15 degrees north of west, or we could say west 15 degrees north. Okay, so any of those would work. Here's a few more examples. You can read through these, pause the video and look at them. Actually, these are just the same examples, just given on a full compass. Recall the vectors have both a magnitude and direction. When we draw a vector, we typically start by drawing a guide, a compass with arrows pointing north, south, east, and west. So this, if you screw back, this right here would be like a guide. After we draw the guide, once those are in place, you can measure the angle. From the center of the compass, we draw the vector, a thin straight line that ends with an arrowhead. Do not let the arrowhead add additional length to the vector. Here are let's do some examples here. Pause the video and you can get out a ruler and do this yourself, or, okay. Now, I don't happen to have a ruler here, but what I can do is I can change this into a graphing paper or a grid. And so, let's see how that looks. Didn't seem to change it very much. Let's see, maybe we can try this, and we can change the spacing so it's a little bit smaller. Let's try that. Oh, that still didn't do it. Okay, well, I'm just going to do it without measurements. So, but you'll get the general idea of it. So here, if I'm doing 2.5 centimeters north, I would measure out 2.5 centimeters, I would draw a line, and then I would draw an arrow. Okay. Now here, 1.9 centimeters southeast. It doesn't give you the exact angle, but we can do a general idea. So here, I could go something along these lines. And the third one, 1.5 centimeters north, 20 west. So it's 20 degrees west of north. So that would be, if I got a compass out, this is going to be about 45 degrees. So it's going to be more like in that range. So I'm going to do it in a different color. And it's a little bit shorter than my other guys. So it's probably going to be something like that. Okay. All right, so this is the examples with an actual ruler. So here's our 2.5 centimeters north. Here's our 1.9 centimeters southeast. And here's our 1.5 centimeters north, 20 degrees west. When you draw vectors, you draw them from a common starting point and label them with the appropriate variable. You may use different colors, keep the vectors thinly drawn, and pay careful attention to magnitude and direction. So here's some more examples. So here you have several vectors. You have A all the way through J, and you have your compass right here. And so go ahead and pause the video and try to draw those out. Okay, so we're starting with this one, 3 centimeters north, which is drawn right here. Then B, we have 3.5 centimeters east. And then we have 2.5 centimeters west. And it keeps going. D, 4 centimeters south. And you can see that D, which is 4, is obviously larger than A, which is 3. You can just visually see that. E, 3.7 centimeters north, 20 degrees east. Which is right here. F, 2.3 centimeters south, 15 degrees west. That would be here. G is here. H is here. I is here. And last but not least, we have J, which is right 2.7 southwest. Right there. Okay, so here we have all of them on one thing. We have all the angles and everything like that. The starting point of a vector is sometimes called the tail. So if we're looking at vector A right here, this would be considered the tail. And the end of the vector is called the head. So the little arrow is the head. Okay, to add two vectors, if we wanted to add vector A and vector B, you start by drawing vector A, then draw vector B, beginning from the head of A. So let's try this out. If I have, I'm just going to trace over this, my vector A, like this, and I wanted to add it, so I can put it, let's say I have vector A like this. And then I wanted to add vector A plus vector B. There's vector B right here. Then I would take and I would put the tail of vector B to the head of vector A right there. Okay, so I'm going to do that. I'm going to take this and I'm looking at the tail, that tail, and I'm going to put it over here. Now, what you do is you can see that this right here was the starting point. That's where we started. That was for vector A. If I were to draw vector A, I start by drawing right there. And where did we end up? We ended up, right, I'll do this a different color. We ended up over here. So when you draw the resultant vector, which is the addition of A plus B, then you start at the starting point and you end at the head, right here. So this green arrow would be the addition of vector A plus B. Vectors are added head to tail. When you are done drawing both vectors, you will draw the resultant vector. This is the vector whose tail is the same location as A's tail and whose head is in the same location as B's head. Then you can measure the magnitude and direction of this resultant vector. You can add any number of vectors. So let's say that let's maybe use our same color scheme as before. Maybe we have this is vector A. And then we can say, oh, we have vector B, and maybe we have a vector C, we can add all these up. So we put, if the problem was A plus B plus C, we could take our vector B, put that on the tail, and I think we might need to move this down a little bit. We might need to move this over here. And then C, we would put that at the tail there. And then a resultant vector would be, we would start at the beginning, which is right here, and we would end up here. So we would start there, and we would, oopsie. That would be our resultant, oopsie. That would be our resultant vector. And I can probably erase that X. Makes it a little less confusing. Okay, so then if you wanted to see just this, you can move that over, Okay, any questions?